the body from a, more of a chemistry standpoint? What is it doing?
You want to take that one?
Yeah, so I would say the crux of it is that you have to learn one basic transcription factor in order to understand how it works. Transcription factor is a protein that goes into the nucleus of a cell and turns on genes so that you make these other proteins. Well, NRF2 is a really special transcription factor because it controls a number of activities in the cell that are quite famous. So one of the sets of genes that it turns on is called the antioxidant response element. So it turns on all the genes that are antioxidants. And the reason that that's important is that our understanding of antioxidants is generally, people think of it as like vitamin C. You have one free radical, you have one vitamin C molecule, and it inactivates the antioxidant. But when you turn on a gene, an enzyme that is an antioxidant enzyme, that one protein is able to process thousands upon thousands of antioxidants. And it keeps doing it over and over and over. And NRF2, this molecule, turns on a whole set of enzymes that take care of every category of antioxidant. So it's the master regulator of antioxidants. And so what sulforaphane is known to be the best inducer of NRF2. So it stabilizes that protein, and then it translocates to the nucleus, turns on all those genes. So antioxidant is the first one. The second one is phase 2 detoxification. So all the genes that are in phase 2 and phase 3 detoxification are upregulated. And so it's, again, not just, say, taking what would be a good cell-decimated chlorella or something where you can bind toxins and have them removed. This is turning on all the genes, these enzymes that do detoxification. So they can take care of many, many more toxicants. And that's actually probably its most famous activity. And because of that, it inactivates a bunch of toxins that can go on to cause cancer. So it's best known as a cancer prevention. And that's
Gotcha.
best data is in that area. And it also inhibits inflammation, inhibiting F-kappa B. So those are the three that we generally talk about. Most of the activities that you can see in most chronic diseases have those three components to it. And sulforaphane, because it's such a good inducer of those three activities, it seems to be a really strong buttress against that move towards chronic disease. And so that's why it has such universal uses. Why, like you said, you can put into try typing into Google your favorite a chronic disease and sulforaphane, and you'll see that most likely there's been a number of papers on that topic. And so that's the crux of how sulforaphane works.